Welcome to Mr. Chalk's Revision Tips. In this video, we will look at
the effect of temperature on rate, the effect of concentration on rate, and the effect of surface area on rate. So, rate of reaction. So, the greater the frequency of successful collisions between reactant particles, the greater the rate of reaction will be. So, temperature, concentration, pressure, and the use of a catalyst will all affect the rate of reaction. So, for a chemical reaction to happen, the reacting particles must collide with each other. The particles must have enough energy for them to react. So a collision that produces a reaction is called a successful collision. The activation energy is the minimum amount of energy needed for a collision to be successful. So the greater the frequency of successful collisions, the greater the rate will be. So the rate of a chemical reaction can be changed by altering the temperature. So if the temperature is increased, the reactant particles will move more quickly. They'll have more energy, so the particles will collide more often and more of the collisions are successful, so therefore the rate of reaction will increase. And you can see there, looking at that graph, that at a higher temperature it gets up to and completes the reaction quicker than at a lower temperature. So the faster rate of reaction was caused by using a higher temperature. So explain this in terms of particles, why higher temperature causes faster rate of reaction. So the key things that you'll need to talk about are particles gaining energy, so have more energy, particles move faster, so they collide more often, or collide more energetically, so therefore more of the collisions are successful. Surface area can affect the rate of reaction. So the greater the frequency of successful collisions, the greater the rate will be. So the more of the reactant particles that are exposed at the surface, the more frequently collisions between the reactant particles will be. So therefore the rate will increase. So if we look at dividing lumps up into smaller particles, so for instance by grinding it into a powder, so for a given mass of a solid, large lumps have a smaller surface area to volume ratio than smaller lumps or powders. So if a large lump is divided into a group or in a powder, its total volume stays the same. However, the area of exposure increases, so the surface area to volume ratio increases. So like we've just said, the rate of a chemical reaction can be raised by increasing the surface area of a solid reactant. So if we're looking at describing the effect that this has, the key things that you'll need to talk about is if the surface area of a reactant is increased, more particles are exposed that can react, so therefore there is a greater chance of particles colliding, which leads to more successful collisions per second, which therefore increases the rate. Concentration will increase the rate of reaction. So if you increase the concentration of a reactant, there will be more of the chemical present. So more reactant particles moving together allow more collisions to happen, and so the reaction rate is increased. The higher the concentration of the reactants, the faster the rate will be. So we're looking at describing the effect of increasing concentration of reactants on the rate of reaction. Key things to talk about is if you increase the rate of the concentration of the reactant, there will be more of the chemical present. So the more reactant particles moving together mean more collisions. So this means that the rate would increase. So the higher the concentration of the reactants, the faster the rate of reaction will be. A catalyst is a substance that speeds up the rate of reaction, does not alter the products of the reaction, and is unchanged chemically in mass at the end of the reaction. Only a very small mass of catalyst is needed to increase the rate of reaction. However, not all reactions have suitable catalysts. So catalyst only affects the rate of reaction. They do not affect the yield of a reaction. A catalyzed reaction produces the same amount of product As a uncatalyzed reaction, however, it gets there faster because the catalyst lowers the activation energy needed for the reaction to occur. So if we're describing what activation energy is and how a catalyst increases the rate of reaction, key things to talk about is that activation energy is the energy that must be provided to components to result in a chemical reaction. So a catalyst speeds up chemical reaction without being consumed. It increases the rate of reaction by lowering the activation energy. So remember that a catalyst is the average kinetic energy of the molecules remains the same, but the amount of energy it requires decreases.
Thanks for watching.